In this section, we're going to look at radical expressions, functions, and models. Let's look at the square roots. The square roots of a number is a number that when multiplied by itself gives the original number. So the definition of this would be the number c is a square root of a if c squared equals a. Some examples of this would be 25, which has two square roots, -5 and 5. Because -5 squared equals 25 and +5 squared equals 25. If we looked at 9, this also has two square roots, -3 and 3. -25 does not have a real number square root. There's no real number such that c squared equals -25. The square root of -25 would be plus or minus 5i, not on the Cartesian plane that we see on our calculator. Let's look at some facts about radical expressions, functions, and models. Every positive real number has two square roots, one positive and the other negative. The real number 0 has only one square root, 0. Negative numbers do not have real number square roots, but in the complex number system, those square roots exist. We denote those with an I afterwards. The positive square root of a number is called the principal square root. Whenever we refer to the square root of a number, we mean the non-negative square root of the principal or the principal square root of the number. The symbol here, it kind of looks like a check mark with a line continuing off to the right. It's called a radical sign, and it's used to indicate the principal square root of a number. The expression under the radical symbol is called the radicand. The negative of the radical symbol denotes the negative square root. Some examples would be the principal square root of 25 is +5, written as square root 25 equals 5. Negative square root 25 equals -5. For any real number a, the square root of a squared equals the absolute value of a. In words, the principal square root of a squared is the absolute value of a. In many cases, I will ask you for both solutions for the square root. If I ask you for the principal square root, it would be the absolute value of a. A radical is the part of an expression that consists of a radical symbol and a radicand. An example of this is in 8 minus 2 square root of 7, the radical is root 7. So let's look at some examples now. The first example we're going to look at is the square root of 81. 81 is a perfect square of 9. Now, we could ask for the principal square roots, but it didn't specifically say find the principal roots of. So we're going to say plus or minus 9. In context, meaning if you were given these questions in a given real life application, you would have to decide which one makes sense, the positive or the negative or both. The negative square root of 49 is -7. The square root of 16 over 49 means we look at what would multiply to get 16 and what would multiply to get 49. This would give us 4 over 7. And don't forget the plus or minus. In part D, we have 0.0064 under a radical. I'm going to rewrite this as a fraction. Remember, if you have tenths, hundredths, thousandths, 10,000ths, you can write this same radical as a fraction. 64 over 10,000. 10,000 is a perfect square, and so is 64. So we can write this as plus or minus 8, because 8 times 8 equals 64, and 100, because 100 times 100 will get you 10,000. Also, if you take 8 and 100, you could reduce that to 4 over 50, which would reduce even further to 2 over 25. So you could finally say that the reduced solution would be 2 over 25. And then lastly, we have the square root of 81. This would be plus or minus 9i.